Small puck with a mass of 0.1 kilograms is sliding to the right with an initial speed of 8 meters per second on an air hockey table. The puck collides with a larger puck with that has a mass of 0.4 kilograms, which is initially at rest. The pucks move off at 60 degrees above and 30 degrees below the initial direction of motion of the puck. What are the final speeds of the pucks? And is this an elastic or inelastic collision? If inelastic, what fraction of the initial kinetic energy is converted to other forms of energy in the collision? So I use conservation of momentum for this problem, which states that the x component of momentum before the collision is equal to the x component after. So it's going to be the same with y, and since the initial momentum is equal to 0, the final momentum is also going to be equal to 0. So momentum, the final momentum of the first plus the final momentum of the second is going to be equal to the initial momentum of the first plus the initial momentum of the second. Since I know that momentum equals mass times velocity, I am able to plug that in. And since I know that the initial velocity of the second puck is equal to 0, I can cancel that out. I also know that the mass of the second puck is 4 times bigger than the mass of the first puck, so I can plug that in for the mass of my first puck, and since I have the same variable in all parts of the problem, I can cancel the variable out, which leaves me with 0.5 times the 0.5 times the final velocity of the first puck plus 3.46 times the final velocity of the second puck equals 8 meters per second. So that's the first equation that I came up with. For my y component, I would use the same formula, but I was able to set one side equal to 0. So I plugged in my angles and all the numbers that were given to me, and decided that I wanted to solve for the final velocity of the second puck, and that left me the final velocity of the second puck is equal to 0.433 times the final velocity of the first puck. And since I found out what the final velocity of the second puck was, I was able to plug that in to my equation here. Once I plugged it in, I was able to find out that the final velocity of the first puck is equal to 4 meters per second. And with that information, I was able to find out that the final velocity of the second puck is equal to 1.73 meters per second. And to figure out if this is elastic or inelastic, I plugged in, or I found out what the initial kinetic energy was, and then also found out what the final kinetic energy was. And since the final kinetic energy is less than the initial kinetic energy, I know that this is an inelastic collision. And then the last part of the problem was I needed to solve for the fraction of the initial kinetic energy that's converted into other forms, and to do that I just divided the final kinetic energy by the initial kinetic energy and came up with this.